In the geometry unit, there's a lot of different topics covered, from area and perimeter to angles, triangles, and looking at all the different pieces within each of those. So I'm going to try to break this down into a couple of different sections and do a couple of examples, and then you should be able to apply these examples to your problems. So let's start by looking at one of the easier ones, so perimeter of a rectangle. So we know that if we have a rectangle, that our lengths are the same and our widths are the same. So I have perimeter is the outside of a figure, so I'm just adding up those sides, so that would be 2L plus 2W. Area is the inside of a figure. So we have area of a rectangle is length times width. So looking at an example here, if I have a rectangle that is 7 feet by 5 feet, and I want to look for the perimeter, I'm going to do 2 times 7 plus 2 times 5. So 14 plus 10 gives us 24 feet. Don't forget those units when you're working with measurements. Area would be 7 times 5, so 35 square feet. Now let's move into a triangle. So if I'm looking at a triangle, again, we're looking at, I'm going to call these sides A, B, and C. So A, B, and C. And I have, I'm going to drop down a perpendicular and call that my H, or height. So if I have the perimeter, again, perimeter is the outside, so all you have to do is A plus B plus C. And area is 1/2 the base times the height. So just to bring out those pieces, the base here is wherever that perpendicular meets. So the height and the base is where that 90 degrees meets, and that's how you'll know what pieces are there. So let's take a look at an example. So just draw us a triangle. So let's say this is 10 inches, and this is 8 inches. We'll have 7 inches, 6 inches. Okay, so to do my perimeter, I'm just going to add up those sides. So 10 plus 7 plus 6, 23 inches. And area is going to be that 1/2 base times height. So remember, your base and your height are where the height meets perpendicular. So there's my height, there's my base. That's going to be the values that I'm using here. So 1/2 times 10 times 8. 1/2 times 10 is 5, and 5 times 8 is 40 square inches. Now looking at a circle. So if I have area and circumference, so we don't call perimeter of a circle perimeter, we call it circumference. So if I have a circle, and we know that if you have a line that goes all the way across the middle, that's called our diameter. And if you have one that only goes halfway across, that's called the radius. So when you're looking at circumference, you have two formulas you could choose from. You could do pi times the diameter if you know the diameter, or you can do 2 pi r. So that means you're just doubling that radius and then multiplying it by pi. And most of the time in Ed Ready, instead of using the pi key on your calculator, you are using that pi is approximately 3.14. For the area of a circle, then you have to use the radius. So you have pi r squared. So if you're given the diameter in that case, make sure that you always cut it in half first and then find your answer. So let's do a quick example here. So I have a circle. Let's say that the diameter is 12 centimeters. And I want to know what is the circumference. Well, I have the diameter, so I'm just going to do pi d, which is 3.14 times 12. And again, make sure that you're not using the pi key, that you are using 3.14, because Ed Ready will count it wrong if you were to use the pi key and then your rounding is a little bit different. So if you do 3.14 times 12, you get 37.68 centimeters. Oops. And looking at the area, remember area uses the radius. So what is half of 12? So we know that the diameter is 12, so the radius has to be 12 divided by 2, or 6. So I'm going to use that 6 in my area. So I'm going to do that pi r squared, so 3.14 times 6 squared, and then plug into your calculator. So 113.04 square centimeters. There may be times that you are given composite figures. So composite figures are where there are two different shapes together, creating one big figure. So I'm going to do one that I see a lot of times with students, and it is a semicircle sitting on top of a rectangle. And the question is usually to find the area and the perimeter, and to remember to use 3.14 for pi. So I'm going to try to, so we have, let's say this is 3 inches and this side is 4 inches. So you have to find the perimeter and the area. Now remember that the perimeter is the outside and area is the inside. So let's just start with our area. So if this side of the rectangle is 3 inches, then this side has to also be 3 inches. Now remember, that's going to be so this is saying that the diameter is 3 inches. To do area though, we need to know what r is. So we're going to do 3 divided by 2. So that's going to be 1.5. So I'm going to do pi r squared, so 3.14 times 1.5 squared. And then you can put that in your calculator, and you should get 7.065. And this would be just the area of the circle. But we only have half of a circle, so we're not finished. We actually have to divide this by 2 because we do only have half of a circle. So I have 3.5325, and I'm going to keep all those decimals right now, and we'll round at the very end. So we have only done the area of our semicircle here. Now we need to find what is the area of the rectangle. So remember, length times width, and that's going to be 4 times 3, so 12. And now we need to add our two pieces. So you're going to add this area of the semicircle to the area of the rectangle, and we get a total area of 15.5325. So I'm going to round that to 0.53. Remember, this is square inches. Now to find your perimeter, we're just going to add up all the sides. So if you fill in these pieces here, if we have this side that's 4 inches, then our other side also has to be 4 inches. Now we have to find this semicircle's circumference, but remember, we are working with a semicircle, so we'll have to divide it in 2. Okay, so circumference is pi d. So you can do 3.14 times 3. And you get 9.42. And divide it in half because it is a semicircle. So 4.71. And now then you can just add these other three sides up. You have to be careful here to make sure that you are only adding these three rectangle sides and not the inside piece. So we're going to say, the perimeter then is going to be 4.71 plus 4 plus 4 plus 3. And you should get 15.71 inches. You could also see a problem where you have a circle inside of a square. This is a rough sketch, so sorry about that. 20 feet, and then it's usually shaded around. When you are asked to find the area of the shaded region, you have to find the area of the square and subtract the area of a circle. So if your diameter is 20 feet, then that means your sides here are also 20 feet all the way around. So here, we can say area, remember, is length times width for a rectangle. So 20 times 20, or 20 squared in this case, since we're working with a square. And we're going to end up subtracting the area of a circle. Remember, that's pi r squared. So our r in this case is going to be 10 because you've got to do 20 divided by 2. So I have 3.14 times 10 squared. And then you can do each of these pieces individually. So you've got that 20 times 20, which is your 400, minus, and then we've got 3.14 times 10 squared, which is 314. And then you're going to subtract. So 400 minus 314. Which is 86. And this is area, so square feet. I do just want to remind you again as you're doing these problems that if you ever see anything about square units, so square feet, square meters, square miles, whatever, that is talking about area. And if it's just like feet or inches or centimeters, that is talking about perimeter. Now we're going to take a look at angles. And there is a lot of information about angles, so let's start by classifying angles. So we have acute angles, which are angles that are less than 90 degrees. We have obtuse angles, where the angle measure is more than 90 degrees, but then that they would be less than 180. We have straight angles, where it equals 180 degrees, and we have right angles, where it equals 90 degrees. So this is how we classify angles. Let's take a look at just a quick example of classifying a set of angles. So let's say this is A, B, C, D, E, and F. And I have 90 degrees, 25 degrees, 65 degrees, and this is 115 degrees. And then I'm going to talk to you guys about how you can even find this other angle measurement right here in just a moment. So if I ask you what is 90 degrees or what is a right angle, you would have to look and determine which one of these equals 90. And it could be written as a 90. You may also see a little square. You could see either one of those there, and they both mean 90 degrees. So angle ABC is a right angle. Notice that I put my B in the middle because that is our vertex. So you want to make sure that you're going in order of B, A, B, C, or you could call this one C, B, A. They are the same angle there as long as you're showing that that B is in the middle. Let's take a look at a straight angle. So if I have a straight angle, that is ones that are straight lines and equal 180 degrees. So I have angle ABE and angle DBF. Notice that these two are straight lines. Okay, now let's look at an obtuse angle. So you're looking for an angle that is greater than 180 degrees. There's only one of those in this problem, and that would be angle EBF. And then we have acute. Acute is less than 90 degrees. We have a couple of those, and those are all your little tiny cute angles. That's a way you can remember it. So we have angles CBD, angle DBE, and angle FBA. So something else while we're looking at this picture is supplementary and complementary angles. So supplementary are angles that when you add together, you get 180 degrees. And complementary angles is when you add it together and you get 90 degrees. A way to remember that is complementary corner. A corner is 90 degrees. Supplementary straight line. Straight line angles are 180 degrees. So if I want to know what, and let's just call this angle X. If I want to know what angle X is, if you notice here that angle X plus this angle FBE should give me a straight angle of 180 degrees. So that means that they are supplementary. So to find angle X, you could do 180 minus 115, and you'll get that little X of 65 degrees. You may also, when working with angles and lines, see parallel and perpendicular lines. So let's just look at an example here. So if I have line WX, line ZY, line UV, and line AB. And then So when I'm looking at this, you should be able to take a look at it and know that WX is parallel to AB. So line WX is parallel to line AB. And if you also see here that line UV is parallel to line ZY. And then where they meet at 90 degrees, anytime lines meet at 90 degrees, they are perpendicular to one another. So we have that WX is perpendicular to UV and it's perpendicular to YZ. So WX is perpendicular to line UV. WX is also perpendicular to line ZY. And then you have one more set over here where AB is perpendicular to UV. Now if we kept pulling these lines out, arrows on the end means that it keeps going on for infinity. So what we would actually see is that line AB is also perpendicular to ZY. Now moving into triangles. Triangles are just three lines or line segments put together to create a triangle. And if I have a triangle and we want to talk about classifying triangles, there are some different types. We have equilateral triangles where all of the sides and all of the angles are equal. We have isosceles triangles where two sides and two angles are equal. And we have scalene where no sides and no angles are equal. And if you ever see something like isosceles obtuse or isosceles acute, it just means that those angles are either obtuse or acute. Okay, so let's look at if I have a triangle ABC and they have angle measures 82 degrees, 75 degrees, and 23 degrees. So this is just a sketch. This is not a very good picture of what this triangle would look like, because it would be a little more like this. Then you're looking at all of these angles are different degrees. So we have a scalene acute triangle because none of these angle measures are larger than 90 degrees. Now, if I have something like this angle would be greater than 90 degrees. And if all of my other angles are also different, then this could be a scalene obtuse. When working with triangles, you may also be looking at congruent and similar. So congruent means they are the same shape, same size. Similar triangles are the same shape but different sizes, and the sides and angles of each triangle should correspond. So if you take a look at an example here, let's call this one ABC and this one DEF. So if I take a look at this and I have this marked out for you, that angle A corresponds with angle D, angle B corresponds with angle E, and angle C corresponds with angle F. and that they're equal. So those little lines mean that they are the same angle. Then you would say that a triangle ABC is similar to triangle DEF. The last little thing with triangles is your Pythagorean theorem. So if I have a right triangle, so Pythagorean theorem only works with right triangles, and let's say our legs are always A and B, and then the hypotenuse is always C. So when I am looking for a missing side of a right triangle, I can use the Pythagorean theorem. A squared plus B squared equals C squared. So let's say that I have a right triangle and one side is 16 meters and the other is 12. So 16 meters and 12 meters. And I need to find this missing side. So that missing side is C. So we're going to say 12 squared plus 16 squared equals C squared. And then you're just going to solve. And you can look for any piece of a right triangle. So if we do 12 squared, we get that 144, and 16 squared is 256 equals C squared. Okay, so now I have to do my 144 plus 256, which is 400. And then you take the square root of 400. So to undo a square, you take the square root of both sides. So the square root of 400 gives you 20. So 20 meters equals C. Again, you can find any piece. If I was looking for, let's say, I knew that this was 20 instead of knowing that this leg was 12, then you would do subtraction and it would end up being A squared plus B squared equals C squared, and you could say, well, A squared plus 16 squared equals 20 squared, and to move this 16 over to the other side, you have to end up subtracting, so 20 squared minus 16 squared, and you would solve it then the same way. So you can find any piece of the right triangle when you know two of them. So now that you know about similar and congruent, and you also know about triangles, you could also set up application problems. So for example, let's say you have a tree and then a person, and we have their shadows. And we don't know this height of the tree, so that's what we're looking for. But we know that the person is 6 foot tall and has a shadow that's 8 foot, and the tree has a shadow of, let's say it's 11 feet. So I can set this up because I have these create right triangles because of this being perpendicular. So you can actually find, we know that this has to be similar because they are right triangles. One is just larger than the other, meeting at that 90 degrees there. So you can set up a proportion to solve this. So you could do the height of the tree over the shadow length equals the height of the person over their shadow length, and then cross multiply to solve. So you have 8x equals 66, and then when you divide, so you're going to do that 66 divided by 8, and you get 8.25 feet. So the tree is 8.25 feet. If you have any other questions, please let me know, but I hope this helps you with your geometry unit.